Shall we move on? The next speaker, which I had the privilege to introduce you yesterday, and I have the privilege to call on stage today again, is Maria Luísa, my travel companion in Núcleo. We're together in this since the birth of Núcleo, 20 years. So today it's another project. It's a project called Frontiers, bringing Nobel Prize Physics into the classroom. And the project is ending, and Maria Luísa, I think, is going to tell us a little bit about the goodies that are now there. Maria Luísa, I will let you know 5 minutes before the end. The floor is yours.
Thank you, Martha. I'm sharing. Let's see if today I don't lose that much time. I'm sharing the computer.
Yes, you are, but not in presenters mode yet.
I've just put play. Oh. Is it there? Yes.
Yes. Yes. Right?
Yeah. Okay. Thank you, Rosa. So today I'm just going to take the gallery away from here. I'm going to talk about this project, Frontiers, bringing Nobel Prize Physics in the classroom. I'd like to describe a little bit what this project is all about, but I would really want to highlight what we considered were the best practices and what we have learned with this project. From Núcleo, Rosa and I were working in this project, and so was José Gonçalves and Priscila Doran. No, this isn't moving. Yes, it is. So this project, it's an Erasmus Plus project. It was a 3 years project. It's coming to an end this month, unfortunately. And what the main goal was to attract students to science. And for that, we would like to use the enthusiasm that usually comes with cutting edge discoveries and experiments. The basis of the Frontiers was that whenever there are great discoveries and new extraordinary results, we have the news everywhere. The media has been covering scientific achievements in a very constant way since the Higgs boson. It was in all newspapers, it was on TV, it was on the social media, on the net, everywhere. And the same thing has been happening to other discoveries, such as the gravitational waves that when they were detected, or last year's the Nobel Prize to the work on black holes and the first image of a black hole, or the year before when the Nobel Prize Physics was awarded for the discovery of an exoplanet orbiting a solar type star, and for all the work in physical cosmology. So there is so much enthusiasm with all these discoveries. And we know that there are many students that listen and they see the news, and then they don't see how it relates with what they are doing in the classroom. So what we would like to do is do the bridge between what they are really learning and what they see on the TV. Like nowadays, you have the cable TV is on most countries. You have Discovery Channel and National Geographic, and all that enthusiasm, we would like to bring it to the classroom. So we have our consortium, which we could describe as having these main expertises in scientific research, in pedagogical research, and in training of teachers and educators and outreach. This has been the way we have been presenting ourselves with these expertise, although we can say DCU has the pedagogical research since it's what its main work is, and IASA and the European Gravitational Observatory or the Paris Center for Cosmological Physics do the scientific research. Elinor Germanic, Iagogi, and Núcleo has been training teachers and educators and doing lots of outreach. But to tell you the truth, I think that all of the consortiums do a little bit of everything. Nowadays, all these institutions, research institutes, also need to reach out to the public and to the teachers and to the educators. And like GHOU is also expanding pedagogical research and scientific research. So the idea is to have everyone advancing in these expertise. So what were the main actions of this project? What we wanted to do was to create resources and make them available to teachers. We expected to train them through courses and workshops and webinars. And we wanted to create a community so that we could continuously support them and have them communicate between themselves so that they feel that they are supported when they want to go to the classroom and have the activities with the students, and so that the teachers, they also need to communicate with each other so that they can learn from each other's experience. So we have these 3 lines of actions: the resources, to create the training of the teachers, and to create and maintain a community. From the institutions that were involved in this project, we decided that we would focus on these 4 modern physics topics: astroparticles, high energy physics, gravitational waves, and astrophysics and cosmology. And the first thing that we had to do was to create some resources. So our first resources were what we call the demonstrators. They were pedagogical scenarios. They explored attractive modern physics topics. They should be ready to be used by the teachers or easily adapted. They should be available online in a specific platform that allows you to create groups and to interact between people, so that we could have the community being created and maintained in the platform, and it should be translated to the partners' languages. But most important was the methodology. So we adopted an inquiry methodology so that we could have the students thinking by themselves and going through the pedagogical scenario, taking their own decisions, doing their scientific research, but allowing them to think how they wanted to proceed with their research. I'm going to skip to the demonstrators. Just to, of course, I don't have time to show you all the demonstrators or even go through them in detail. I just want to give you an idea. So this is the Frontiers site. It is going to change very, very soon, we hope. It's still in a way that we don't think it's the best way, but since we still have things to add over here, we're going to change many of the way you get to the demonstrators and then you explore. But anyway, if you get to the site, you can find the demonstrators. They're all over here. There are 25 of them in those 4 modern physics areas. And you can look at them first with just a description. Over here, I have opened the description of this demonstrator, Black Holes in My Classroom, How Do We Detect Stellar Mass Black Hole Candidates? And you can see a description of the demonstrator before you really go and see the demonstrator. Some of these activities or demonstrators, you will see that we have explored them in other projects where the same topic has been explored over here throughout the Global Hands-on Universe conference. Not all demonstrators are new in the topic that we are dealing, but what we really wanted to do was to apply that inquiry methodology so that we could have a different way of interacting with the students. So when you open the demonstrator, which is right over here at the beginning, you can find the activity in that platform, the Inspiring Science platform. And over here, you can see that there are 5 phases. These are the inquiry-based learning phases. The first one, orienting and asking questions, then the hypothesis generation, planning and investigation, analysis and interpretation, and conclusion and evaluation. So the idea is to go through each phase and have the students do the research in each of the demonstrators. So in this platform, it is easy for the teachers to clone. This means that they can copy the demonstrator, they can adapt it as they want, and then they can use it in the classroom. So that was pretty straightforward. It was just a question of making sure that we had activities that had the students interested and anxious to do the research, because the topics, we believe that they are very, very interesting, and they really refer to real science that they can do in the classroom. So this was about the demonstrators. Let me go back over here. And let us talk a little bit about how the training went. Of course, because of this past 2 years, most of our training was online training. We were very happy to see that we had many, many teachers interested in Frontiers project. I'm not sure, but I think that it's about 500 teachers have asked to receive our newsletter. And for all the trainings, we always had many teachers that wanted to participate on the online courses. Our training included international summer and winter schools. There were national training events. Some of them were able to be face-to-face, but many of them are also online. We had webinars. We also provided virtual visits to research facilities, and there's an online course in preparation that will be in the Frontiers website, so that teachers can also work by themselves. As for the community, what we thought would result and would have good results was to create a Google Classroom for the international summer and winter school teachers so that they could continue in contact with each other. We created a Facebook group. There are also national Facebook groups, and we tried to have the community also working in the platform where the demonstrators were published. And also we tried to have more people engaged using the virtual visits. So especially for these 2 aspects of the training and of the community, what could we consider that were the best practices? It was very important that during our summer and winter schools, we had the teachers creating their own activities based on the demonstrators. This means that we had keynotes, we had presentations, so that the teachers could understand what we would like the students to do with the demonstrators, but then they would work collaboratively and adapt to what they think they could use in their classroom. This is extremely important because you can have these activities ready to use, but most teachers will adapt. So it's very important for them to have the chance to work on the way they want to use it in the classroom. And then we can also help them to see if the way they are presenting things are scientifically correct, and if the ideas they are passing are the ones that they should. And with this help, they get these activities really ready to use in the classroom and adapted to their own way of teaching, and in sometimes to the level of the students, since our demonstrators were mostly for secondary schools, and not all teachers were teaching that level.
5 minutes, Luísa.
5 minutes, thank you. We also asked them and try to help them develop e-twinning projects, which is extremely important for them so that they can collaborate between them and get to know other teachers from other countries. It was also very successful. The Google Classroom that we created for the teachers that went to the international schools, they really appreciated that they could keep on being supported by us and continue communicating between themselves. For us in Portugal, for instance, we are going to do the same thing for our national teachers, because we believe it's a very good practice to have them all together in a way that everyone can communicate and share their experiences. And also what we asked them is whenever we had a new school, because we had 2 summer schools and 1 winter school, the teachers that had already been in one of the schools, they would also present their work to the teachers of the next schools. And we found that it was very, very rich. It was good for the teachers to show their work, and it was very good for the other teachers to listen to the previous experience. So these are some highlights on what we consider the best practices from the summer and winter schools. Another point that I would really like to show you is that we had the virtual visits to research facilities. It was to CERN and to the Virgo and to the Pierre Auger Observatory. And we also had a live session with the Folks Telescope. And we streamed this through Facebook. And it was a huge success. It was very good for the students, for teachers, for families, and for the general public. We also did that for teachers that had the students in the classroom, so that it was on Facebook, but at the same time, the teachers and the students were in the classroom and they could ask questions. So it was alive. And we found that it was a very, very successful way to engage all these different people that we want to have with us in Frontiers. So the virtual visits streaming on Facebook is something that is very, very successful, and we're sure we will do that more times so that we can have more people engaged in this project. What teachers have asked for was shorter activities, because our activities in general were quite long, and not all teachers have that much time to do the activities to all its extension. There was a big request from primary schools and middle schools to adapt the ideas of the demonstrators to their levels, and the sharing of the teachers' adaptation. So we are working on having all these other features to give to the teachers soon.
1 minute, Luísa, to wrap up.
For the future, we would like to have a continuation of the project. We're still not sure when, but we hope it won't take too much time. And until then, we hope to keep the community alive by promoting some online events, by keeping the teachers communicating between themselves, either Facebook or Google Classroom, and of course, by supporting teachers. So I'd like to thank you all for listening to me. And also I'd like to leave here a big thank you for all the teachers that were with us during this project. And we hope we won't lose you. And whenever you want to contact us, we will always be available to continue supporting teachers with Frontiers in the classroom. We won't go away. We'll be here waiting for different ways that we can help. And I
Thank you, Luísa. On time, unfortunately, we have no time for questions, but if you have any question, Carl, I see you have your hand, and I'm sorry, we still have 3 people ahead, and I not want to delay the program. People are here for a long time. So can you please put your question, which I'm sure is a very good one, in the Q&A so other people can also see, and Maria Luísa can answer there. Please, Carl, do me this favor and apologize.